Question number 13. A coat hook is attached to a smooth door by a screw as shown. The diagram below shows three of the forces that act on the coat hook when a coat is hung from it. The weight of the coat hook may be neglected. Add a labeled arrow to the diagram to show the additional force required for the coat hook to be in equilibrium. So we are talking about equilibrium. So if it's equilibrium, all the forces acting in all the directions should be equal. Now let us look at two different directions here. We have vertical and horizontal direction. Now in our vertical direction, we have two forces, which is weight of the coat. Look at the size of the arrow and compare this with the size of the arrow, which is vertical force from the screw. So if you look at both the sizes, they're almost equal, and we can see that it's not moving up or down. So the vertical forces in the vertical direction are balanced, they are in equilibrium. Now they are already saying that it is in equilibrium, so this shows that the in vertical direction the forces are in equilibrium. Now let's come to the horizontal direction. In horizontal direction, one force is already given here, which is horizontal force from the screw. So the screw is applying a horizontal force on the door. So according to Newton's third law of motion, the door will apply an equal but opposite force on screw. The force from the door on the screw. Okay, now you have to, they are saying add a labeled arrow to the diagram. So we have identified what is the force. Now we are going to add a labeled arrow. So this arrow should be approximately equal in length to the horizontal force from the screw. Why? Because they already say that this is in equilibrium. So this will be the force which is acting on the screw from the door. So that should give you 2 marks. So 1 mark is for drawing equal length arrow, and the second mark is for identifying and labeling the force correctly. Next question, let's look at it. If too many coats are hung on a coat hook, the hook will rotate and pull the screw out of the door. Point P is the position of the pivot as shown. The maximum horizontal force from the screw is 150 Newton. So this force is given as 150 Newton. Okay, the mass of one coat is 2.6 kilogram. Deduce whether a person could hang more than two of these coats from the hook. Now, when such a question is given, all the forces are, we talk about forces in the first part of the question. So we don't know which topic from forces are they discussing. Is it momentum, moment? So you have to look at all the words given in the question, in the stem of the question. So this is the stem of the question, and there is a word called pivot. So we know that pivot comes when in the topic moment of force. So this question should be solved using the moment of force concept. Okay, now, what is the question? You are going to figure out if the person could hang more than two of these coats from the hook. So, which means if more than two of these coats are hung from the hook still should be in place. Which means the whole system should be still in equilibrium. By if you hang more than two coats. Now, what are the information given? We already figured out that the horizontal force from the screw is 150 Newton from the question. The mass of one coat is also given as 2.6 kilogram. Now let us look at what are the moments. So we have point 0.9 to be the perpendicular distance to the horizontal force from the screw. So this will rotate the screw in this direction. So and this will provide anti-clockwise moment. Okay. Now weight 2.5 centimeter is the perpendicular distance to the weight. So weight will provide a clockwise moment to this hook. Now as long as clockwise moment and anti-clockwise moment are equal, the hook will stay on the door and it will be able to withhold the weight of the coats hung on it. So let's apply the moment of force to this question. So 150 multiplied by 0 0.9 should be equal to the weight of the coats. We don't know how much weight of the coats can the anti-clockwise moment 150 multiplied by zero point 0.9 provide. Okay, so we are going to figure out what is the weight that this moment can provide or can withstand. 150.9 is 135. So 135 is W multiplied by 2.5. Solving for W, 135 divided by 2.5 will give W. The value is 54. So the total weight that can be hung if the horizontal force from the screw is 150 Newton is 54 Newton. Now we need to figure out if this 54 Newton will will be equal to two mass of two quarts or more than two quarts. So first let's convert 54 Newton into mass. So you have to divide 54 by 9.81, which is 5.505. Now this is the total mass. So we know the mass of one quart is 2.6. So how much to how many of 2.6 is there in 5.505 or 5.51? That is 2.11. So this much of 2.11, which is approximately equal to 2. So a person can hang only two coats, cannot hang more than two coats. So no, we will be arriving at the conclusion as the person cannot hang more than two coats when a force of 150 Newton is applied from the screw, and it says maximum horizontal force. So if the maximum horizontal force is only 150 Newton, the person can only hang two coats.